Hi there, I'm Soren. I am doing meatballs with Will for our final project. Our ingredients include 2 pounds of ground beef, 4 eggs, half cup of rolled oats, half cup of Romano cheese, and then 2 to 3 garlic cloves, a little bit of water, salt, and pepper. So the molecular composition of our ingredients include proteins in the form of myosin and actin in our meat, along with fats, water, and some connective tissues. The rolled oats contain starches in the form of amylose and amylopectin, and it's a soluble fiber. The Romano cheese, right here, is rich in milk proteins like casein, and it also has fats and salt in it. The eggs, the proteins are in the white, which is the albumin, and there's also water and emulsifiers in the lectin of the yolk. And the garlic mostly has carbohydrates, water, sulfur, and contains flavor compounds. The salt and the pepper right here are so the salt's an ionic compound, it's NaCl, and then the pepper is plant fibers, and then the water is just a polar molecule that is used for moisture and hydration. So out of these ingredients, the ground beef is the key, it's the star. So it's gonna provide that main protein structure, and the proteins are gonna coagulate and keep that meatball together. The rolled oats are gonna act as a binder, and they're gonna absorb all those water and fats, and it's gonna swell with that beta glucan, and it's gonna thicken the whole mixture, so it's gonna be a juicier, moister, just all around better meatball. And then the Romano cheese is gonna add some salt, it's gonna add fat, that umami flavor, and that melted fat is gonna provide tenderness. So the eggs are gonna be another form of protein, and it's also gonna add some binding structure when it's heated. And so, and then the yolk is gonna emulsify the whole mixture. It's gonna add that richness and that thickness. The salt is gonna be, it's gonna extract that myosin from the meat, and it's gonna help hold that meatball shape. The pepper and the garlic are just flavor components, and the water is gonna help hydrate the oats and just improving that tenderness, that juiciness, and that moist texture in the meatball. So what are the changes that I expect to happen in this meatball? So I think the proteins in both the meat and the eggs are gonna denaturize and coagulate when that heat from the skillet is applied, and it's gonna just solidify that meatball's texture. The starch and the gelatinization in the oats are just gonna make that meatball just a firmer, thicker, juicier meatball that's gonna be denser. And then I think the fat from the cheese and also from the meat are gonna increase that juiciness, which is gonna be retained by the oats. And the Maillard reaction, which is the browning, is gonna add flavor and color, which is gonna be applied from the skillet. And then I think the water evaporation helps the meatball actually firm up, because it's gonna be loose in the beginning, but as heat is applied, water will evaporate. And I think the meatball is just overall gonna be much better. So now that I've explained how everything's gonna work together on a molecular and chemical structure, let's actually get into making these meatballs. So we're gonna just start by adding all of the ingredients. I'm gonna dice up I'm probably gonna stick with 2 of these garlic cloves because they're kind of big. Maybe I'll do a third. And mix it all together, and yeah. All right, now that the garlic is minced up, we're gonna start adding the ingredients. I'm gonna start with the wet ingredients, which is the eggs. And we're gonna just incorporate that with the meat. Now that the meat and the eggs are incorporated, let's start adding the dry ingredients like the cheese and the oats. We're also gonna add that garlic. Now that all of the dry ingredients are included, I'm gonna start adding a little bit of salt and some pepper as well. I'm also gonna add just a bit of water just to loosen up the mixture just a little bit, and we're gonna incorporate all those ingredients again. Great, now our meatball mixture is created and we can start making some meatballs. Now I'm gonna start to form the meatballs into actual balls so we can start to sear them on the skillet. Great, now all the meatballs are formed and we can start to sear them on the skillet. For this experiment, we're gonna be doing some conduction heating through a skillet on the stove. And so we're gonna first crank up that heat to about medium to medium high. I'm gonna do a little bit between medium and medium high. I'm gonna also add a little bit of olive oil just to have a coating on that pan before we start applying the meatballs. Alrighty, now that the pan has heated up, we're gonna start adding our meatballs slowly, and then we're gonna have them cook. And once they're brown on one side through that Maillard reaction, we're gonna flip it so that it can have that Maillard reaction on all the sides. Alrighty, so it's been about 10 to 12 minutes, and the meatballs are completely done. So we got that nice brown coloration, which is that Maillard reaction. So we're gonna take them off the heat, and we're gonna let them rest for a little bit. All right, finally done cooking all of the meatballs, and the final verdict. So as I stated in my hypothesis, I thought that the meatballs were gonna be denser, firmer, and less tender and less juicy. Overall, I think most of the hypothesis was correct. I think that it did create a denser meatball, very firm, very dense, because it absorbs so much of the oil, fats, and waters. But unlike my hypothesis, I do think that it was actually a more moist meatball, and actually pretty tender, but definitely very dense, very rich. So overall hypothesis was mostly correct, but I do think that it was wet, unlike I predicted. And yeah, overall good success. Had a lot of Maillard reactions. You can see that perfectly brown color, brown all around from that stovetop.